Hi students, today we will discuss about carbon and its compounds. Carbon and its compounds. So here various physical forms in which an element can exist are called allotropes. So carbon, carbon means C, its valency is carbon equal to atomic number 6, valency is 4, so that we will call tetravalency. Tetra means 4, tetravalency. Electronic configuration is 1s2, 2s2, 2p, 4. Sorry, 1s2, 2s2, 2p, 2. So valency means last shall have how many electrons, that is, so 2 plus 2, 4. 4 is its valency. So it will get 4 electrons, either sharing of electrons or gaining of electrons or loss of electrons, whatever it, every element try to attain noble gases configuration. For that noble gas configuration, for stable electronic configuration, for stability, every element try to attain gain of electrons or sharing of electrons or loss of electrons. Anything it will be doing that. Okay, now so this is carbon is tetravalency. So carbon and its compounds. Its compounds what? Its compounds we will call like its compounds we will call allotropy forms. Allotropes of carbon. Allotrope of carbon what? Allotropes of carbon. So the various physical forms in which an element can exist are called allotropes of the element. Carbon exists in three forms. Carbon exists in three forms called allotropes. So that allotropes is, one is diamond, second one is graphite, third one is fullerenes. So these three types of allotropic forms is there for carbon. Major these three: charcoal, graphite, that is nature, based on the nature. Nature means either it is a solid form or amorphous form or crystalline form, like based on that different types is there. So these three is we will discuss now. So diamond, first one is diamond. So about diamond is colorless, transparent and colorless, transparent and sprinkle and reflect light. Reflect light. So that's why we will call this is a lustrous property. Diamond exhibit lustrous property, means shiny nature. Lustrous property means shiny nature. So next point for diamond, it is extremely extremely it is extremely hard and has a high melting point. High melting point. High melting point. High melting point. Next, it does not conduct electricity. It does not conduct electricity. It does not conduct electricity. Why it does not conduct electricity? Why it does not conduct electricity? So we will discuss in structure of diamond. We will discuss why it does not conduct electricity. Now, structure of diamond. Structure of diamond. Structure of diamond. What? Diamond is diamond as one giant molecule of carbon atoms. So carbon atoms, one atom to another atom, it will be joined together, will form every atom in a diamond. Every atom in a diamond. Every atom in a diamond is bounded to its neighbors by four strong covalent bonds. Very important point. 4 strong covalent bonds. Strong 4 covalent bonds. Strong 4 covalent bonds. So covalent bond, how to form? Okay, I will explain. Bonds continuation. Leaving no free electrons and ions. This explanation why diamond does not conduct electricity. Why diamond does not conduct electricity? Because there is no free ions, free electrons or ions, whatever it, there is no free ions and electrons, so that only didn't conduct electricity. All the bonds, carbon atoms bounded like 4 valence electrons, 4 electrons bounded with 4 other carbon atoms, so there is no free ions, so that only it cannot participate in electricity, so it cannot conduct electricity. So this is the about electricity conduct, and it does not conduct electricity. That okay. Next, uses of diamond we will check. So in exam, in CBSE board exam, NCERT board exam, will ask about a diamond. Means first diamond, structure of diamond and uses of diamond you should write. Uses of diamond. So uses very important. Uses of diamond. So diamond we can use cutting instruments like glass cutters and in rock drilling equipments drilling equipments also we have to prepare with the diamond. Drilling equipments, diamond are used. Next point, diamond are used diamonds are used for making jewelry making jewelry Next point, very very important, sharp edged diamonds are used by eye surgeries. So what type of equipment we are using here? Sharp as a tool to remove cataract, like fireball in our eye. Fireball is there, or cataract we will call that. So this one we can remove with the help of this one. Who's that is removing? Eye surgeons using this tool, sharp edged tool, to remove the cataract in our eye. So this is the uses of diamond. Graphite, next one is graphite. So graphite is a black shiny black shiny and opaque object. This is like graphite is a shiny and opaque. Next point, it is a very slippery. Slippery means smoothness material. Slippery or smoothness material. Next, graphite is insoluble in water. High melting point, having high melting point and good conductor. Electricity, good conductor of electricity. Next, structure of graphite. Structure of graphite. structure of graphite. So graphite contains layers of carbon atoms. Which atoms? Carbon atoms. In graphite, each carbon atom is bounded to three other carbon atoms. How many? Three other carbon atoms. So each carbon atom is bounded to three other carbon atoms means one free electron is there, right? One free electron is there. That's why it is good conductor of electricity. It will conduct electricity. Diamond didn't conduct electricity, but graphite conduct electricity because of free electron is there. Only 3 bond, each carbon attached to 3 bonds. So remaining one electron is free, so that only it is conduct electricity. Okay, 3 other carbon atoms in the same plane. All are same plane. Okay. The same plane are giving a hexagonal area. Means hexagonal structure. One of these bond in this double bond also is there. So and valence of carbon is satisfied with the help of the double bond 4. So graphite structure formed by the hexagons is being placed in the layers of above one layer and down one layer is there, like how I will show you here. So this is so this is one structure and this is one more layer. All are same plane means it will showing like this. This is one layer, down one layer and above one layer. So after this one, like this. So this is also one layer. Like this, down one layer, above one layer. From this only, from the graphite only, one layer we can remove means we will get the fullerenes. Third allotropic form is there, no? Diamond graphite fullerenes. So fullerenes comes from here only, Beckmanstein fullerenes. So that scientist identified this layer separated. He will 2004 I think he is introduced fullerenes carbon 60 from this only, from the graphite only. So next uses of graphite. So uses of graphite. Powdered graphite is used as lubricant. Lubricant means this lubricant used for are used as lubricant. So this lubricant used for the fast moving parts, for the fast moving parts of machinery. So in machineries we can use oil and all, grease and all, but fast moving machinery, when we are adding oil and grease, that oil and grease also will be evaporate because of high energy will be releases. Fast moving machineries, high energy means high heat releases. So more heat releases means even lubricating oil also will evaporate. Then that smoothness will be reduces. So smoothness will be reduces means machineries will be rotate very slowly, so problems will come. So that only machineries, this high melting point, no, graphite have high melting point, no, so that we can use lubricant like this graphite powder means this one slippery nature, it will be smoothly rotating high parts, fast moving parts of machineries. Then what happened, cannot evaporate because high melting point, no, graphite. So like oil and grease, not like this one. So oil and grease will be evaporate up to 200 degrees temperature, but this is can't evaporate. So that only high moving, fast moving machineries and all we are using lubricant. Instead of lubricating oil we are using graphite powder. So that is the reason. So because of high melting point. Yes, this one more point, used as a graphite, used as electrodes in dry cells, because of good conductor, conduct electricity. So that only we are using. Next point, next use, it is used for the making, it is used for the making pencil, core of pencils called pencil lead. So this is about graphite. Next, fullerenes also is there, that we will discuss only few things, only 1 or 2 points. Fullerenes 2004 only it is introduced. Who's introduced? Buckminster Fullerenes, scientist name, what is that? Buckminster Fuller, scientist name. He is introduced this one, carbon 60, C60. So some hexagons and pentagons also is there in this structure. This structure, how it is there, which has carbon atoms, arranged in the shape of football shape, the shape of football. So introduced by Buckminster Fullerene. This is also known as buckyball, because ball shape. So that only we will call buckyballs and football shaped and carbon 60. It is used for nano tube also, we will call nanotubes. For in medical field also we are using this Buckminster Fullerenes. Thank you. Subscribe Vishwaguru tutorial. If you want to like means you can subscribe. Thank you.